Hello friends, welcome to NEET World. So in the previous class, we dealt with complex numbers with respect to very short answer questions, and we also revised the complex number chapter in a brief way where I told you about various concepts. So in the today's class, similarly we will deal with the next chapter, that is De-Moivre's theorem. So which is very important chapter when it comes to your intermediate exam. Also De-Moivre's theorem is also very important concept when it comes to what MCET and KCET, and also when it comes to JEE. Okay, KCET not much will be asked, but application based it may be asked, De-Moivre's theorem, but mainly complex number questions will be asked. But here in MCET and JEE, complex numbers will be linked with De-Moivre's theorem and then it will be asked. Now, having said this, before going to what is De-Moivre's theorem, I'd like to inform you about how much the weightage it is carrying when it comes to intermediate exam. Now, when it comes to intermediate exam, this chapter is carrying weightage of 9 marks. Okay. De-Moivre's theorem is carrying weightage of 9 marks. Okay. 9 marks. There are two questions. Only two questions will come. That is, one is from very short answer question. One is from very short answer question VSAQ, which is carrying 2 marks, and another one is from long answer question, which is carrying how many marks? 7 marks. So total it is carrying 9 marks. So if you have understood complex numbers well, then you will be able to easily understand what is De-Moivre's theorem. Okay, all right. Having said this, let us start with the session. Let us dive into the session with respect to De-Moivre's theorem. So first of all, you should understand why this theorem came into existence. Like I told in the yesterday's class, you should know why we have to study complex numbers. I told you in the yesterday's class. Similarly, you have to understand why we have to study De-Moivre's theorem. That is, of course, it is coming in your exam, you have to study, that is fine. But in real life application, what is the use of this De-Moivre's theorem? What is the need of this De-Moivre's theorem? It is also linked to why we need complex numbers. So you can see the picture here. Okay, so here you can see an image of a man standing what? Upright. Here you can see a man standing at an angle. So if you zoom at this picture, so what you will see is, if you zoom at these pictures, what you will see is this is a zoomed image of the previous picture. So if you zoom it further, you can see what? This is nothing but pixels. Each of them pictures are having so many thousands of lakhs of pixels. So if you what? Extrapolate each of these pictures or pixels, what you get is this kind of circles. So these kind of circles, these are not circles usually, these not circles. Usually people think it as circles. This is just what? This is a sphere. That means this is a 3D image. This is a 3D image. This is not a 2D image. This is a 3D image. Okay. This 3D image, I told you, yesterday's class, I told you, when we have to represent rotation, okay, when we have to represent rotation, we use complex numbers. Similarly, this pixel is also a what? It's a sphere. So here we are representing it using a complex number, that is x plus iy. That is, it is having both what? X-axis, y-axis, and also the imaginary part. This is real part, this is imaginary part. So suppose I want to what? Increase the size of this pixel. Increase the size of this pixel, then I'll multiply this given complex number with another complex number, that is z. Okay. If I want to increase further, I'll multiply with another complex number, then it will become further increased. Okay, the pixel will become further increased. So having said this, now have a look at this picture. Now you can have a look at this picture. Here the person is standing vertically. Here the person is standing vertically. Suppose I want this person to be turned by 90 degree. If the person is to be turned 90 degree, what I will do? I'll multiply with I. I'll multiply with I. So this person will be turned like this. Okay, he will be turned to its left, but by 90 degree. But if I want to enlarge this image, if I have to enlarge this image, I'll multiply with 2. If I want to enlarge it further, I'll multiply with 3. Like that. This is how what? Animation works. Okay, whenever you want to learn animation or whenever there is need of animation, complex numbers and also De-Moivre's theorem comes into picture. Okay, here itself we can see. Okay, you are multiplying I to first to rotate to 90 degree and then you are multiplying by 2. to increase the size of the image. Similarly, you can also what? You can reduce the size of the image by dividing it by 2, something like that. Got it? But what happens when you multiply, or sorry, when a person what? Rotates by 45 degree, or when a person rotates by 135 degree, something like that, what will happen? How to do that? For that, we need something else. For that, we need to represent the complex numbers in a polar form, which I told you in the yesterday's class. That is how to represent the complex numbers in the polar form. Earlier, the person turned 90 degree. Here, the person, if it is 45 degree, the person is inclined. Here, we represent it by theta. That here theta is 45 degree. So, using that, we represent it in a polar form. This is what? This is polar representation. This is polar representation of complex number. This is polar representation of the complex number, which we learned in yesterday's class. That is, z is equal to r cos theta plus I sin theta. Here r is what? R is the modulus of the complex number, and theta is the amplitude, which we learned, and x is equal to cos theta into r, y is equal to sin theta into r. Okay. Here r is what? Here r is nothing but, if this is a circle, here r is nothing but the radius of the circle. Okay, got it. So this 90 degree, suppose if I want to split that image into two, that means this 90 degree will be split into two images, that is 45 degree and 45 degree. Okay. Similarly, if I want to split the image into what? Suppose the image is tilted into left side 90 degree. If I want to split it into two, we will split it into 90 degree here and 90 degree here. This right angle will be split into two, that is 90 degree to the left and 90 degree towards the right. So what will happen? What will happen when you split it into two? The image will be cut into half, right? So these are all the various uses of complex numbers when we have to do animation. So mainly we use complex numbers, all these things in animation also. So here what will happen? To split it into two, what you are doing, multiplying the complex numbers adds their angles. What does it mean? So when you have to split it into two, you are multiplying the complex number with itself. That's z, you will multiply with z. What will happen? It will become z square. So that gives us what? That gives us, see, cos 90 degree plus I sin 90 degree. That is, I can write it here, cos 90. Because why? You are splitting it into two halves. Each half is having 90 degree. Cos 90 degree plus I sin 90 degree. Okay. Again, you are multiplying with same complex number, that is cos 90 degree plus I sin 90 degree. Okay. So this is equal to what? Because you are splitting this 90 degree from total angle is here what? 180 degree, because this is a straight angle. So this cos 90 degree plus I sin 90 degree, cos 90 degree plus I sin 90 degree is nothing but into I sin 90 degree will give you what? Cos 90 degree plus I sin 90 degree whole to the power of 2, that is whole square. So that will be equal to cos 180 degree sin 180 degree. Why? Because this is 90 plus 90, that is why it is 180. That is why here we have told that multiplying the complex numbers adds their angles. That means what? Here cos is what? 90 degree. Here cos is what? 90 degree. Here sin is what? 90 degree. Here sin is what? 90 degree. So it will become what? Addition. The multiplication of the complex numbers adds their angles. That is what has happened here. So that if you write it as, if you take square root on both sides, square root of cos theta plus I sin theta will give you cos theta by 2, I sin theta by 2. So if theta is here, you will get this theta by 2. Okay. If it is 2 theta, you will get it as theta. If it is 4 theta, you will get it as 2 theta, something like that. Okay. So this is the general form. This itself we call it as De-Moivre's theorem. Suppose if we are dividing the angle into n number of times, then we get this equation. So now let us come back. Same thing here. This is a general form of, this is also called De-Moivre's theorem. So now talking about De-Moivre's theorem, to explain it in simple terms. Okay. I hope now you have understood the application of De-Moivre's theorem. Now I will give the statement of De-Moivre's theorem. Now let me give you the statement of De-Moivre's theorem. What does De-Moivre's theorem say? Okay. Suppose let n be any integer. Let n be any integer and theta be a real number, and theta be a real number. Okay. Then cos theta plus I sin theta to the power of n is equal to cos of n theta plus I sin n theta. That is, how many number of times you are multiplying, that number of times the angle gets added. Okay, this is the De-Moivre's theorem. This is the De-Moivre's theorem. That is what we saw here. That is what we saw here, friends. So here it is what, cos theta plus I sin theta. The second, write it as square root of cos theta plus I sin theta. This square root can be written as 1 by 2. So here the angle is getting multiplied by 1 by 2. 1 by 2 into theta is theta by 2. That is what you are getting here. So here, see here, cos theta plus I sin theta to the power of n. So cos theta plus I sin theta to the power of n. Here n is what? N is 2. So this is becoming what, friends? So cos theta plus I sin theta to the power of 2. So this is becoming what? So 2 times. So 2 into 90 degree. Here also 2 into 90 degree. So cos 2 times 90 degree plus I sin 2 times 90 degree. So that is coming as 180 degree. So this is how De-Moivre's theorem is illustrated. Got it, friends? So some other properties of De-Moivre's theorem we are going to learn now, because you have to revise the concepts. Like I told you, you lose out on very short answer questions because of lack of conceptual clarity or due to some confusion. That is what means lack of conceptual clarity. Okay, got it? So when I talk about statement of De-Moivre's theorem, I told you, let any real number n and complex number in polar form, cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta. Same thing. That is what we explained. So De-Moivre's theorem we are going to define in our syllabus. We are going to define even for integer index, that is integral index, and also rational index. But the statement remains the same. This theorem provides a simple way to compute the powers of complex numbers. Okay, so that is what powers of complex numbers means. What that is, how to compute the powers of complex numbers. For that, De-Moivre's theorem use. That is what we saw when I explained about the need for complex numbers and De-Moivre's theorem to make animated videos, to make animated images, all these things, when I gave the example of pixels. Got it? Now, what are the application? Finding the powers of complex numbers. See here, one of the applications is find the powers of complex numbers. That is, z is written in polar form. Z is equal to r times cos theta plus I sin theta. Then De-Moivre's theorem helps to compute z to the power of n is given by r to the power of n into cos theta plus I sin theta. That is cos n theta plus I sin n theta. That's it. When it comes to powers of what? Complex numbers. Also, otherwise you may have to use binomial theorem. Binomial theorem for the value of n which is small, like n is equal to 2, 3, 4, 5. Okay, you can calculate, but when n is very high, it is difficult to compute. For that instance, what we can do is we can use binomial theorem. No, for that instance it is better to use De-Moivre's theorem. Okay, got it, friends? Next thing is finding the roots of complex numbers. Suppose you have to find the nth root of complex number. For that, like I told, polar form is given by this. So zk r to the power of 1 by n, that is nth root. Square root of 2, if I say the square root means 1 by 2, like that, nth root means r to the power of 1 by n. Okay, will be given by this equation. Got it? Anyways, this is what we learned. Power of complex numbers is given by this, and nth root of complex number is given by this. This is Euler's form. Okay, so some more properties we will learn, friends. Some more properties we will learn, like I told you. Okay, again I'll write the statement of De-Moivre's theorem. Cos theta plus I sin n theta to the power of n is given by cos n theta plus I sin n theta. Okay, for any theta belonging to R. Okay, this is first thing. Suppose it is given as cos theta plus I sin theta to the power of, this should be not n theta, should be just sin theta. Okay, to the power of minus 1. If it is minus 1, so you have to make it as, you have to multiply the angle by minus n itself. minus n. If it is minus n, what will happen? If it is minus n, what will happen? You have to multiply this thing by minus n itself. So this will become cos minus n theta plus I sin minus n theta. Got it, friends? But we know that cos of any theta, that is cos of minus theta, is plus cos theta itself. So this will become, this equation will become cos of n theta, sin of minus theta is minus sin theta. So that is minus I sin n theta. I sin n theta. Okay. So cos theta minus cos theta plus, not minus, plus I sin theta to the power of minus n is cos n theta minus I sin n theta. This is very important result. You have to remember this. Next thing is, suppose first equation and second equation what I gave, if you multiply, that is to say third one, that is cos n theta plus I sin n theta into, to multiply with cos n theta, okay, minus I sin n theta. If I multiply, what will I get, friends? So it is of the form what? A plus b into a minus b. I'll get it as a square minus b square, that is cos square n theta, okay, minus I square into sin square n theta. But we know the value of I square. I square is minus 1. This equation will become cos square n theta plus sin square n theta. But we know that this value is equal to 1. So cos n theta plus I sin n theta into cos n theta minus I sin n theta will be equal to 1. Will be equal to 1. So next what we have to do is, this can be written as, using this we can write cos theta, that is cos n theta, here friends, cos n theta, or even cos theta you can write, just cos theta plus I sin theta will be equal to 1 by cos theta minus I sin theta. Okay. Similarly, you can write cos theta minus I sin theta is equal to 1 by cos theta plus I sin theta. Got it? These are the very important results you have to remember. Next thing is cube roots of unity. They will ask questions based on cube roots of unity also. So when they ask questions on cube roots of unity, okay, you have to understand the concept of cube roots of unity. See here, cube roots of unity. So what do you mean by cube roots of unity? Usually we write 1 omega square as cube roots of unity. What is the value of this? This is written as 1 itself. Omega is written as minus 1. Okay, minus 1 plus root 3 by 2. Omega square is minus 1 minus root 3 by 2. So these values, these are nothing but the cube roots of unity. Got it, friends? So some properties based on cube roots of unity. What do you mean by cube roots of unity? This 1 omega square, they represent what? The sides of an equilateral triangle. They represent the sides of an equilateral triangle, okay, which is what? Which is within a triangle. Sides of an equilateral triangle within a circle of unit radius. Within a circle of unit radius. What does cube roots of unity represent? They represent, each of this represent the sides of an equilateral triangle, which is what? Inscribed within a circle of unit radius, and the circle having having center at origin. Got it? That is, they represent sides of an equilateral triangle which is inscribed within the circle of what? Unit radius, and the circle having center at origin. All these things are very important, you have to keep it in mind. Now when it comes to cube roots of unity, there are two important properties. 1 plus omega square is equal to 0. You have to remember this, highly important. Okay, this is one property. That is, sum of the cube roots of unity is equal to 0, and product of cube roots of unity, that is 1 into omega square, that is omega cube, is equal to 1. The value of this is equal to 1. You can verify yourself, this is equal to 1. Okay, these are all the basic concepts. These are all the basic concepts which are required to solve questions based on De-Moivre's theorem. So we just revise this concept. So having learned this concept, let us try to solve the previous year questions of De-Moivre's theorem, that is very short answer questions which has been asked in your inter exam, that is intermediate examination, friends. I hope the concepts are clear now. So let us have a look at the first question, friends. So the first question that is given is cos theta plus I sin theta to the power of n by cos sin theta plus I cos theta to the power of n. Okay, simplify. Okay, I think some mistake is there in this question. Let us have a look. Okay, cos theta plus I sin theta to the power of n. So the question should be simplify cos alpha plus I sin alpha, cos alpha plus I sin alpha to the power of 4 divided by cos beta plus I sin beta to the power of 8. Okay, cos beta to the power of I sin beta to the power of 8. Okay, this is the question. This was asked in the year March 2024. This was asked in the year 2024 examination. Okay, they are asking simplify. So first for this question, what we can do is, in the denominator, let us do some modification so that we can solve the question easily. We know that the value of I is root of minus 1. I square is minus 1. Okay, but if I write minus I square, the value is 1. So here nothing is there means I can write 1. Correct? No. So nothing is there means I can write 1. Now, so in the next step, in place of 1, I can write minus I square cos alpha plus I sin alpha to the power of 4 divided by instead of 1 I can write minus I square into cos beta plus I sin beta to the power of 8. Okay, to the power of 8. So this here I square is here I is there, I can take I common, but power of 8 is also there. You should be very careful with this. So this I can write it as cos alpha plus I sin alpha to the power of 4 divided by if I take I common, here it will be I into minus I cos beta plus sin beta, this to the power of 8, and here also it will be to the power of 8. Got it, friends? Is it clear till here? So I have taken I common here. Now I to the power of 8 is there. So when I to the power of 8 is there, see here this will become I to the power of 8. I can write it as, see here friends, this I to the power of 8 I can write it as I to the power of 4 to the power of 8. But we know that I to the power of 4 is what? I to the power of 4 is 1. I to the power of 4 is 1. So I to the power of 8 will become what? I to the power of 8 is I to the power of 4 to the power of 8. So this will become 1 to the power of 8. So that will be equal to 1. So this value I'll write it here. So you have to show the steps here. So cos alpha plus I sin alpha to the power of 4 divided by I to the power of 8. I to the power of 8 I can write it as I to the power of 4 to the power of 2 into sin beta minus I cos beta to the power of 8. Okay, to the power of 8. Now this will become what, friends? I to the power of 4 is 1. So this will become, friends, cos alpha plus I sin alpha to the power of 4 divided by I to the power of 4 is 1 to the power of 2. So this will become divided by this value will become equal to 1. I'm writing it here. So this will become equal to 1. So this will become, denominator will become sin beta minus I cos beta to the power of 8. So here I have to tell you one more property. Okay. So usually when I said, when we were representing in polar form cos theta plus I sin theta, okay, this we can also write it as cis theta. So similarly, when I apply De-Moivre's theorem, so cos theta plus I sin theta to the power of n to the power of n is equal to cos n theta plus I sin n theta, right? So this will become what? Cis theta to the power of n will become cis n theta. So one more property we have to learn is cis theta. Suppose theta is one value and another value is cis alpha, then this is equal to cis theta plus alpha, okay, where theta alpha belongs to real numbers. Now in this question we have reached a point where we have to apply De-Moivre's theorem. So cos alpha plus I sin alpha to the power of 4, that is cos theta plus I sin theta to the power of n is cos n theta plus I sin n theta. So this will become what, friends? This will become cos 4 alpha plus I sin 4 alpha, okay, and this I can make it what? This, if I take it to the top, sin beta plus minus I cos beta, if I take it to the top, what will happen? Sin beta minus I cos beta, if I take it to the top, what will happen? So this will become sin beta minus I cos beta to the power of minus 8. So to the power of minus 8 if I take it, so this will become, friends, cos 4 alpha, I have applied De-Moivre's theorem here, plus I into sin 4 alpha. So if minus 8 comes here, so this will be sin of minus 8 beta minus I into cos of minus 8 beta, okay, minus 8 beta. So this will become cos 4 alpha plus I sin 4 alpha into sin of negative is sin minus sin, so this will become cos of negative is positive of cos, so this will become cos 8 beta, okay, and this will become minus sin 8 beta, minus sin 8 beta, okay, cos 8 beta minus sin 8 beta, okay, minus sin 8 beta, and here it will be I, here it will be I to the power of no power. Already we have applied De-Moivre's theorem here, we have applied De-Moivre's theorem here, so this will become equal to cos 4 alpha plus 8 beta, okay, plus I sin 4 alpha plus 8 beta. This is the answer to this question. Finally you will get this. While simplifying, finally you will get this. I have given a detailed solution for this, friends. I have given a detailed solution for this. So based on this you can solve this question. Based on this you can solve this question. Now when I say, actually this should be, here it is plus I sin, it will become plus I sin, here I will not be there, okay, so I will not be here, so this will become like this. So this is the solution for this first question. Although it proved to be lengthy, but it is very simple. Just we have applied De-Moivre's theorem. Just we have applied De-Moivre's theorem to this question. Now we'll go to the second question. Look at this question, friends. They are telling if ABC are triangles or angles of a triangle such that x is equal to cis A and x is equal to cis A and y is equal to cis B and z is equal to cis C, then find the value of x, y, z. They are asking us to find the value of x, y, z. So if a plus b are the angles of a triangle, so we'll solve this. This is asked in May 2024. So and also asked in May 2015. So this question has been repeated. So we know that sum of angles of a triangle is equal to pi, okay, and they are telling x is equal to cis A, okay, and y is equal to cis B and z is equal to cis C. Now they are asking us to find x, y, z. They are asking us to find what? They are asking us to find x, y, z. Okay, just a minute. They're asking us to find xyz. So xyz is nothing but equal to cis A, cis B and cis C. Okay, but I told you in properties, while telling about properties, cis theta plus or cis theta into cis phi is equal to cis theta plus phi. The angles get added. So here it will be cis A, cis B, cis C is equal to xyz will be equal to cis A plus B plus C, cis of A plus B plus C. So cis of A plus B plus C is nothing but what? A plus B plus C is pi. So xyz will be equal to cis pi, because here we know that A plus B plus C is equal to pi. Okay, you can write it 1, equation 1. Here you can write using 1. Okay, we got cis pi, but cis pi can be represented as xyz will be equal to cos pi plus I sin pi. Okay, I sin pi. Cos of odd pi is equal to plus 1. Cos of even pi is equal to minus 1. Cos of odd pi is equal to what? Cos of odd pi is equal to plus 1. Cos of even pi is equal to minus 1. No, that is not true. Okay, you should remember that cos of odd pi is equal to minus 1. Cos of even pi is equal to plus 1. Okay, cos of n pi is equal to minus 1 when n is odd. Cos of n pi is equal to plus 1 when n is even, and sin of n pi, these are all plus 1 topics. I mean plus 1, you must have studied this. Sin of n pi is 0 regardless of the value of n. So this will be equal to what, friends? xyz will be equal to cos pi is equal to minus 1. Okay, cos pi is equal to minus 1 plus I into 0. So I into 0. So minus 1 plus I into 0 is xyz will be equal to minus 1. This is the answer. So this is the answer, friends. So this is the answer to the question. I hope it is clear. Now let us have a look at third question. They have given if x is equal to 6 theta, then they find the value of x to the power of 6 plus 1 by x to the power of 6. So they have given x is equal to 6 theta. Then x to the power of 6 will be equal to 6 theta to the power of 6. That is equal to using De-Moivre's theorem. Okay, you should write here using De-Moivre's theorem in every step. I mean not every step, wherever you are using De-Moivre's theorem, in the side you have to write it in bracket, because that is very important to show it to the examiner that you are using this theorem. Otherwise you lose the marks. Okay, so 6 theta to the power of 6 will become 6 theta. Okay, it becomes 6 theta. So this I can write it as x to the power of 6 is 6 theta. So that will be equal to what? Cos 6 theta plus I sin 6 theta. Okay, so x to the power of 6 is this. So we studied cos theta plus I sin theta can be written as equal to 1 by cos theta minus I sin theta. Similarly, cos theta minus I sin theta can be written as equal to 1 by cos theta plus I sin theta. So if x to the power of 6 is this one, then 1 by x to the power of 6 can be written as cos 6 theta. Okay, cos 6 theta minus I into sin 6 theta. So this is the value we got. Now what they are asking, x to the power of 6 plus x to the power of 1 by 6. Now this will become x to the power of 6 plus x to the power of 1 by x to the power of 6. X to the power of 6 plus 1 by x to the power of 6 will become cos 6 theta, okay, plus I sin 6 theta, got it, plus cos 6 theta minus I sin 6 theta. So plus I sin 6 theta minus I sin 6 theta will cancel. So what you are left with, the answer is 2 cos 6 theta. This is the answer for x to the power of 6 plus 1 by x to the power of 6. Simple, very simple question. Okay, you should not miss out on this. Next question. See here friends, they are given find the value of 1 minus I to the power of 8. Suppose they are given 1 minus I to the power of 2 to the power of 3 even to the power of 4. You could have found out. Here they are given to the power of 8. That's what I told you. Nth root of complex number or powers of complex number. Okay. Here you can use binomial theorem, all these things, but that will be very tedious to use those binomial theorem here. Instead of that, we will use De-Moivre's theorem and solve this equation. Okay. What is that they have given? They have given 1 minus I to the power of 8. What I will do is, I will multiply both numerator and denominator by root 2. Why I will tell you. So, root 2 into 1 minus I to the power of 8 by root 2 by root 2. Let me write it again. I'll divide both numerator and denominator by root 2. So let me write it here. Root 2 into 1 minus I to the power of 8 divided by root 2. Okay. I'm multiplying and dividing by this one. Okay. If you want me to explain again, see here. When if you write it outside, then we have to send it inside. So first only I send it inside. So for your understanding, let me write it again. So I'll write it as root 2 into 1 minus I to the power of 8 divided by root 2. Okay, 1 minus I to the power of 8 divided by root 2. So this I can write it as inside, I can send it. So this will become root 2 into 1 minus I whole to the power of 8. Okay, this whole divided by root 2. Everything is under the root. So we can avoid this step. This is not required. You can write it this way itself, better. So 1 minus I to the power of 8 can be written as this way. Now we will see how to solve this. Root 2 by root 2 is there. I have told let us multiply numerator and multiply numerator and denominator by root 2. So this will become what, friends? This root 2 to the power of 8, if I take it outside, this will become root 2 to the power of 8. Okay, this will inside it will become 1 by root 2 minus I by root 2 to the power of 8 to the power of 8. Got it, friends? 1 by root 2 minus I by root 2 to the power of 8. Now 1 is here minus I is here. So what I can write here, instead of 1, what I can write, for what value of cos will I get positive value of 1? So I can write, instead of 1, where 1 is there, I can write what? I can write cos 2 pi, because this is what? This is 1, positive 1. So I can write even pi. So this will be equal to, instead of that, here we are getting 1, here we have to get 1. Okay, both the places we have to get 1. So instead of taking cos 2 pi, what value we can take? Where there is the value of 1. Instead of value of 1, what we can do is we can take value of 1 by root 2. When we have to take value of 1 by root 2, for what value of cos or sine? Cos and sine, we will get 1 by root 2. To get 1 by root 2, we can take cos pi by 4. So to think like this, cos pi by 4. Okay, cos pi by 4 is equal to 1 by root 2. That is equal to sin pi by 4. That is equal to sin pi by 4. Got it, friend? So if I put the value root 2 to the power of 8, that will give you what? That will give you root 2 to the power of 8 is nothing but equal to 2 to the power of 4. So 1 by root 2, instead of 1 by root 2, I can write it as cos pi by 4. Okay, minus I into sin pi by 4 to the power of 8. Okay, now using De-Moivre's theorem, if I bring it inside, this will become 2 power 4 is 16 into cos 8 pi by 4 minus I into sine 8 pi by 4. Got it? Now this 4 ones are 4 twos are 4 ones are 4 twos are, so this will become 16 into cos 2 pi minus sine 2 pi. I sine 2 pi. I told you cos of even pi is plus 1 and sine of any pi is 0. So this will become equal to 16 into what it is, cos of 2 pi. Cos of 2 pi is plus 1. Okay, plus 1 minus I sine 2 pi is 0. So the value of this will be equal to 16. Okay, the correct answer to this question is equal to 16, friends. Okay, got it? You can have a look at this. So you have to remember very carefully in this chapter cos of odd pi, cos of even pi, all these things. Cos of odd pi, cos of even pi, all these things. So 1 minus I to the power of 8 will give you the value of 16. Very simple. Next question, see friends. This is based on cube roots of unity. They were given 1 omega square are the cube roots of unity. Then prove that 1 by 2 plus omega, 1 by 2 plus 1 by 2 plus omega, 1 by 1 plus 2 omega is equal to 1. This is asked in 24, 18, 17, 15. So very important question. Has been repeated many times. So friends, let us take this. Let us take LHS. See here, 1 by 2 plus omega plus 1 by 1 plus 2 omega is equal to 1. We have to prove. Okay. So let us take LHS. LHS is equal to 1 by 2 plus omega plus 1 by 1 plus 2 omega. If you take LCM here, this will become equal to 1 plus 2 omega plus 2 plus omega divided by 2 plus omega into 1 plus 2 omega. This is what we get. Okay, if you take the LCM. Now, see here, 1 plus 2 is 3. 2 omega plus omega is 3 omega. Next, 2 into 1 is 2 plus 2 2s are 4 omega. Okay, got it. Next, omega into 1 is omega. I'm just multiplying. Omega into 2 is 2 omega is plus 2 omega square. Okay. Now, what I can do is, here I can take 3 common. So this will become equal to 3 into 1 plus omega divided by 2 into 4 plus 2 plus 4 omega plus 2 omega square. Okay. So here 2 into 1 plus omega is there. So what I can do here? So friends, 2 into 1, 2 2s are 4 omega into 1 omega into 2 omega square. So this is 2 plus 2 omega square, I'll write together. Okay, plus 4 omega plus 1 omega is 5 omega. Okay, now see here friends, we know that by cube roots of unity that property 1 plus omega square is equal to 0. Here we have 1 plus omega. This is 1 plus omega. 1 plus omega will be equal to send it this side, this is omega square. So this will be equal to 1 plus omega square. So this will become equal to 1 plus omega will be equal to minus omega square. So 2 plus 2 omega square. 2 plus 2 omega square. See here friends. 2 plus 2 omega square. So this will be 2 into 1 plus omega square plus 5 omega. 1 plus omega square is what? 1 plus omega square will be equal to minus omega. So this will be 3 into minus omega square by 2 into 1 plus omega square is minus omega plus 5 omega Okay, let us have a look at the question. What is that is given? Whatever that is given. Okay, here the question that they are saying is it is not equal to 1. Actually it should be 1 by 1 plus omega. There is a mistake in the question. 1 by 1 plus omega. 1 by 1 plus omega. So see friends, this will be minus 2 omega plus 5 omega will give us minus 3. This is minus 3 omega square by this is minus 3 omega square. Okay. minus 2 omega plus 5 omega will give us 3 omega. Okay, 3 cancels and omega cancels, you will get minus omega. So LHS will be equal to minus omega. Now let us take what is RHS. RHS, what is there? In the RHS we have something like 1 plus omega. So RHS, let us take RHS is equal to 1 plus omega, but we know that by cube roots of unity 1 plus omega can be written as minus omega square. Okay, 1 plus omega can be written as minus omega square, and we also know that by product of cube roots of unity, that is 1 omega square is equal to 1. So that is equal to what? Omega cube is equal to 1. So here wherever 1 is there I can write it as what? Omega cube by minus omega square, omega cube I can cancel, so I will be left with only minus omega. That is nothing but equal to, or not RHS, it will be equal to LHS. We got here also minus omega. Okay, here also we got minus omega LHS. RHS also we got minus omega. So this is equal to LHS. So therefore LHS is equal to RHS. Okay, we have proved it. Next one. Next question is 1 omega square are the cube roots of unity. They are asking us to find the value of 1 minus omega plus omega square whole cube. So they are asking us to find the value of 1 minus omega plus omega square whole cube. This I will rearrange it as 1 plus omega square minus omega whole cube. Okay, so what is 1 plus omega square? See, by cube roots of unity 1 plus omega square is equal to 0. Then 1 plus omega square will be equal to minus omega. So this will be equal to what? 1 plus omega square is minus omega. Here again minus omega whole cube. So this will be equal to what, friends? Minus 2 omega cube. This is cube. Okay, so minus 2 to the power of 8, not 2 to the power of 8, minus 2 to the power of 3 into omega to the power of 3. Okay, minus 2 to the power of 3 is minus 8, omega to the power of 3 is 1. Omega to the power of 3 is 1. That is what we learnt here. Here we used what is what? Omega cube is equal to 1. So similarly here also omega cube will be equal to 1. So the answer to this question is minus 8. Very simple question. This is how we solve this question. Next one. If 1 omega square are the cube roots of unity, prove that this LHS is equal to RHS. We have to prove. Simple. Let us take it. A plus B. Last question. This is the last question. A plus B omega into A plus B omega square. LHS I have taken. LHS itself. Okay. I will multiply with A throughout. Okay. Okay. So first let us multiply this one. Let us keep it A plus B as it is. LHS is equal to, that is equal to A plus B into A is A square plus AB omega square. A into A is A square. A plus AB omega square. Okay. Next B omega I have to multiply. B omega into A is plus AB omega. Okay. Next is B square. This into this B square omega cube. Okay. Now A plus B into this AB I can take common. So A square plus AB into omega plus omega square. Okay. Plus B square omega cube. Omega cube is nothing but equal to 1. Okay. So this will be omega plus omega square. We know that 1 plus omega square is equal to 0. Therefore omega plus omega square will be equal to minus 1, friends. Will be equal to minus 1, friends. So this A plus B into A square into omega plus omega square will be equal to minus 1. So this will become minus AB plus B square. So but directly from the formula we know that A plus B into A square minus AB plus B square will be equal to A cube plus B cube, that is equal to RHS. Hence proved. Okay. Hence proved. So these are all the very short answer questions that have come in the previous years. Okay. These are all very important. Okay. I hope the concepts are clear now. So thank you, friends. We'll meet in the tomorrow session with another chapter. Okay. I hope it was helpful to all of you. Please watch this session again if you have any doubt, and have a look at the concepts again. These are very important for MCET and JEE as well. All right, friends. Thank you. Take care.